Hi, I'm Jen Humphreys. I'm a PhD student in Professor Mary Jo Brownce's lab in the Earth and Planetary Sciences Department of the University of California, Riverside. I'm a non-traditional student. I have two different degrees from different institutions. My first degree is a BA in the Visual and Dramatic Arts from Rice University. And a few years after graduating from Rice, I ended up going back to school and I got a BS in the Geosciences from the University of Texas at Dallas. I chose to study at UCR because of a combination of the wide range in research topics being covered by the Earth and Planetary Sciences Department, the proximity to multiple different research institutions, and because of the friendly collaborative environment here within the department. My research involves looking at olivine hosted melt inclusions. These are pockets of melt which got trapped inside of olivine grains as they were crystallizing inside of a magma chamber. Additionally, I'm interested in using olivine hosted melt inclusions as a tool in understanding subduction zone processes. Subduction zones are where materials from the Earth's surface are recycled back into the deep Earth. You get arc volcanoes and earthquakes along subduction zones, and understanding what exactly is happening to that downgoing crustal material as it's going deeper and deeper into the Earth lets us get a better view of how and why the Earth works the way it does as a whole. Now for a tour of our lab and some of our equipment. I'm in one of the rooms of Mary Jo Brownce's labs here at UCR. To my left is our FTIR, that's a Fourier transform infrared spectrometer. It is how we understand what the volatile contents of the volcanic glasses are that we work with. It works by passing an infrared beam through our volcanic glass samples. We know the properties of this beam before they go through the samples, and then we measure how the beam's properties have changed after they pass through the samples. Here's an example of one of the samples that I work on and the tiny scale that I work with. This tiny little dot, it's about a pinpoint size sample, is an olivine grain that's been double polished so that is both sides are flat and shiny. And within that olivine grain is an olivine hosted melt inclusion of maybe 40 to 100 micrometers in diameter. That's the width of maybe one or two strands of hair. And that's what I measure for my samples. Now let's head to the Brownce Clean Lab. Everything in this room is either plastic, Teflon, or coated in a plastic epoxy so that we can avoid cross-contamination. We are hoping to be able to do whole rock digests here under our fume hood, where we take our rocks, dip them in acids, let them soak in the acids, break those rocks down, and understand what the elemental contents of those rocks are, such as the trace element contents. Hi, Jen again. We're here in the Lions Lab where Mary Jo's laser ablation system is hooked up to the Lions Lab inductively coupled plasma mass spectrometer. These systems work together so that, like, when I'm working on my volcanic glasses, for example, I will ablate my sample using the laser, where those tiny particles will get carried up in a carrier gas over to the ICP-MS, where they are vaporized, and then we count their weights and sort them by weight so that we know the parts per mil quantities of the trace metals in our glasses. Thank you for joining me today on Tour of the Lab. I hope you enjoyed what you watched, and you can follow us on Twitter at Roxygen Lab.